Good afternoon, everyone, and welcome back to the second workshop in Sustainable Practices Design 9. This time we will talk about site, topo, sections, and BFE storm surge conceptual messing. And I would like to welcome Darren Ogurch. He will give the workshop today, and it's sponsored by Crunch, by the research. So we are paying for this workshop to have it well done and professional, because remember, these workshops need to apply NAP, AI, and NCARB criteria. And what we see today is pretty much the realm of critical thinking and representation. Design thinking skills, which is A2, A3, investigative skills. Then we have A6, which is use of precedents, case studies. And then we have the entire realm B, building practices, professional practices, technical skills, and knowledge level. This includes the ability to do an assessment of a site and use the tools available. And that's what we do today. And that feeds then into software workflows. I did send to my colleagues and to all my students the required software that needs to be installed, from Rhino, Grasshopper to Revit, newest versions. So I think you all have it installed and you can follow with two screens, hopefully. One you watch, the other one you do your tests, your experiments. And then we have B2, site design, the ability to respond to site characteristics, include sea level rise and all the datum, et cetera, et cetera. And this is very specifically developed by Darren. And then include those data sets to actually then feed them into a software workflow with plugins that helps us to start our first conceptual designs. And then we have environmental systems that we had very helpful workshop with Theodoros Galvanos from my studio, with the infrared tools and the Ladybugs tools. And I will continue then probably next week, because this Thursday, Biana will give a presentation about, I believe, GIS import into your workflow, so you get statistics. Yeah, I would say this is the nutshell of today's workshop. And thank you again, Darren, for taking your time and giving us this very, very helpful and professional workshop. And Darren, if you also please record on your side, I will record on my side as well.
Yeah, Thomas, it's actually not letting, it says you have to give me permission to record.
I put you as a host. Okay, let's do it again. You know, Zoom is funny. It says only one participant can share at a time. Yeah, thank you for that. So I'm doing a screen recorder backup recording, just in case, because you need the full RAM and memory for your presentation.
Right, exactly.
Okay.
So good afternoon, everyone. My name's Darren Ockert. I know quite a few of you I can see in this list, but for those that don't know me, I've actually been part of Thomas's Crunch study on sea level rise, which is a 3-year, I think you're in your 3rd year now, right, Thomas, of this study?
Yes.
And so these are some of what I'm going to show you workflows to get some of your conceptual massing from Rhino, which I know a lot of you use, into Revit. Let me just start sharing my screen. Okay, that's all shows correctly, Thomas?
Perfect. Thank you.
Okay, I'm using 2 monitors, so if anything goes out, just let me know. So I'm going to cover today some boring stuff, but very necessary stuff about datums, sea level rise, and storm surge. And then we'll get into the cool stuff, which is using Grasshopper and a plugin called Gizmo to bring in some site context. We'll look at conceptual massing workflows from Rhino to Revit, and then we'll look at how you can diagram that in Revit. And then at a future date, Thomas will take what you've brought into Revit and discuss with you how you can do some environmental analysis on that. So I don't really like PowerPoint presentations. So I'm going to try and go through this boring stuff as quickly as possible so we can get on to some demonstrations. So first of all, we're going to look at datums, and this is really important for the projects you're working on. And datums are really reference points. You know, it's where one would consider where zero is. And there are many different datums, and it's quite an alphabet soup. So we're going to start with some of the ones that you might hear of in the architectural world. And that's the first one is NGVD, which is the National Geodetic Vertical Datum, which came out in the early 20th century. And these datums were to try and find out where zero was on land, so the point where the ocean meets the land. And these were formed by looking at how water reacts on a globe, and it kind of settles to a certain shape on a spinning globe, and that was the reference point, the kind of sea level reference point. So this was used in the architectural industry, and it was superseded by something called NAVD, which is the North American Vertical Datum, which is mainly used now. And that's going to be superseded hopefully next year. It was a little behind schedule by this new datum called the Geodetic Reference Datum, which is instead of using the ocean as the kind of base point, it's going to look more from space and use the technologies, the GPS technologies that we have in space. So why should you really care about that? Well, as an architect, you're going to be dealing with plans, and on those plans, you need to know where the elevation of your building is. And these plans from licensed surveyors will show you the reference datum. So this is based on the NGVD. So this is the older one. And from this plan, we can see that the lowest habitable floor elevation is 12 feet and 12.3 feet. So this is decimal feet. And we also can see on this that we've got that this is actually not in a flood zone. So it's in an X zone. This is actually my old house in Miami Shores. And it doesn't have a base elevation, flood elevation, which we're going to talk about later. So you can see the garage was at 9.9 feet. So you're going to come across plans and you need to know where that 0 point is, and it's based on this datum, the NGVD on this. And as I mentioned previously, this is has been superseded by NAVD, which is more likely to be seen. So these plans are provided by a licensed surveyor who uses these points. It's a point all across the North American continent, and it's based on one tidal station in Canada, in Rimouski in Canada. And so they looked at the mean sea level in that part of the continent and then leveled that across the continent and produced these little discs that surveyors use to find the elevation data. So we're going to look at, because you're looking at sea level rise in this particular scenario, we're going to look at some more datums. And these are related to water. So these are related to sea level. One of them is MSL, which is mean sea level. And basically this means that you have a high tide and a low tide, and you measure the mean level of the high and low tides throughout a time period, and that's called an epoch, which is 19 years. So we're currently in last year of the epoch that they've been measuring this mean sea level from. And then you have a mean low water, which is the low tide, a mean high water, which is the high tide. You have a mean lower low water. So places like Miami have 2 high tides and 2 low tides each day. And one of those low tides is lower than the other tide. So the mean lower low water is the mean of the lowest tide of that day over that 19 period epoch. Why is this important? Well, if you're a boat owner, all of your charts will be based on this MLLW, mean lower low water, because that is the lowest the water is possibly going to get. And if you're in a boat and you have a pretty deep hull, you could run the risk of running aground. So anything to do with sea level, the datum that is used is the MLLW. And as we'll see, this is very different from the NAVD. So I'm going to take you over to, just get rid of my pen, the NOAA website. And this gives us a lot of really, really great data and has some really great graphics on there, which kind of help to explain these different datums. So I'm going to zoom into Florida. And we're going to go into Miami. And this will be one of the stations that you're going to be using to look at tide data for your project. So this is the active NOAA sea station, tidal station at Virginia Key. And this gives us lots of data. As we were saying, at the moment, the water level is 1.3 feet above the mean lower low water level. And if we click on this plot, we can see the tides during this day, the high tides and the low tides. The blue is the prediction, what NOAA is predicting will be the water level throughout yesterday and today. And the red is the actual water level that was received. So you can already see from this, the predictions are lower than what we're getting in actual tides at the moment. We can get even more detail by going to the station homepage. And this is live data coming in. We've got a picture of the station there on Virginia Key. And we've got our high and low tides. We've got some weather data. And this is the current water level, 1.3 feet above MLLW. Now, this has a ton of useful information that will help you understand these datums. If we go to tides and water levels, we can go to datum. I'm going to zoom in a little to help you see this. So this is the Virginia Key. And as I said, all data values are relative to MLLW. And we were talking about NAVD, which is used a lot on survey plans and used by architects. And you can see that 0 on MLLW is actually 2.02 feet in NAVD. So you really have to understand that there's a difference between where the water is and where we consider 0 for our elevations on land. And if we're looking at mean sea level, we can see that mean sea level is 1.13 feet above MLLW, which is still a little bit lower than our 0 for NAVD. Now, what's great about this is they have a little graphic here which can help explain that. Let me zoom in a little more. So we can see our 0 is here, and we can see that NAVD is up here. So that's the difference between those two. And if we look at MSL, mean sea level, that is here. And again, NAVD is above that. Now, if that all seems confusing, they've got a great little pull down menu here. So we can set 0 to NAVD. Let that refresh. Yeah, got to submit. And now we can see when we set this to 0, we can see that mean sea level is actually 0.89 feet below, and MLLW is actually 2.02. So when you're making these charts to show sea level rise, you've got to understand that where 0 on land is starting a lot higher than where MSL is. Okay. Why should you care about this? Okay, so as you all know, due to climate change, the oceans are rising. There is a compact, a climate change compact of the 4 counties in South Florida, Monroe, Broward, Dade, Miami-Dade, and Palm Beach. And they formed something called the Southeast Florida Regional Climate Compact. And they wanted to consolidate all the data on sea level rise and produce a guidance of what to expect in sea level rise over the next 100 years. They originally released this, their first report early on in the 2000s. The next report was on 2015, and they just updated the 2019 report. The report had to be updated because climate change is actually happening faster than we thought. And these figures had to be revised to show that sea level rise was actually going to be more in the future. So what you see on this chart is the IPCC medium, which is the Intergovernmental Panel on Climate Change, which is a UN body, which does a lot of reports on sea level rise. So that is their prediction. We have NOAA, which is the National Oceanic and Atmospheric Administration and agency in the US. And they have 3 different scenarios. One is an intermediate high, and an extreme. And these are the 3 scenarios they think are going to happen based on if we can control carbon emissions in the atmosphere of how much the sea is going to rise. So this is very specific to our region. This is actually relative to sea level rise near Key West. And across the globe, sea level rise is not uniform. And we unfortunately are in an area where it is actually higher, estimated to be higher than other portions of the planet. So what this is showing is a 50-year planning horizon, which is generally how municipalities plan. They plan 50 years out for infrastructure. So this is saying, like, if you're going to build a new highway or a new office building, we should really be looking 50 years ahead and looking at this number here, which is suggesting that we will have between 21 inches and 64 inches of sea level rise. So that will be the mean sea level in 50 years by 2070. Again, this is, I want to point some things out on this chart that is in inches, and this is relative to the mean sea level, which, as we just saw, is slightly lower than 0 with the NAVD data. But they have made it a little bit easier for us. So they made another chart, and this is based on feet in NAVD. So we can see here on the chart, let me just highlight this for you. So we have 0 now being NAVD, and then you see here that the mean sea level is below this because we're below what would be 0. And all of these charts are based on what the sea level was in 2000 at Key West. So that's our reference point on these charts. So this is helping us realize that I'm 2.5 feet above what is 0 on the land. And obviously, when we look out to 100 years from now, these figures get pretty shocking, considering most of the land around here is 4 to 8 feet above 0. Let's just clear this off. So not only is sea level rising, but in our particular region, we are prone to hurricanes, and with hurricanes comes storm surge. What is very important about storm surge is when they're saying we're going to have, when the National Hurricane Center or the Weather Service is saying we're going to have 3 feet of storm surge, that is actually 3 feet above ground. It's not 3 feet above mean sea level or any of the other datums. They are estimating that this flooding will be above ground. So this is a storm inundation map from the National Weather Service. It's a new product they released, I think it was about 5 years ago. So if we ever have a hurricane coming towards Miami, we would get a map issued something like this. This is for Houston area. And you can see on this that with this particular Hurricane X coming, there are areas on this coastline that will be under 9 feet of water on the ground. So we're going to look at Thomas's project, which looks at this in the Miami area. This link, I'm going to send you these slides so you have all the links, and I'm also going to send you any of the scripts we use in Grasshopper. This is a link to, the first link is to the the NOAA storm surge site. And the next link that I'm going to click on is the crunch research that Thomas has been working on with the FIU GIS department. And this gives us a 2D representation of what sea level rise at certain feet would look like on Miami Beach and South Miami. I'm going to particularly look at Miami Beach because that's where your site will be. So we can use these sliders at the top and see what happens when we go to 1 feet of sea level rise. What happens with 2, we start to see some of these areas being permanently underwater. We go to 3 and we see a lot of Miami Beach underwater. 4, pretty much the whole thing is underwater at that point. What Thomas and the Crunch research is working on at the moment is to put this into section, because what this, let me get the annotation.
You zoomed that once.
Say again?
I don't want to miss this.
So what this is showing us is, okay, this land is flooded. It's no longer going to be land. It's going to be permanently underwater with 4 feet of sea level rise. But it doesn't really tell us how much water, right? This could be 1 inch of water. It could be 4 feet of water from this chart. So what Crunch is working on at the moment is to do a sectional representation of this. So we have the land coming up here. You know, we have a person and we have a house. We want to see where that is. You know, that's the 1 feet, that's the 2 feet, that's the 3 feet. And we start seeing where that actually looks like on land as a cross section across Miami Beach. So we have that. And then we have to also bear in mind that we are prone to hurricanes. So even with, let's just say 1 feet of sea level rise, which is touching some of this area on the West Avenue, and it looks like some area up here in Parkview Islands. Once we start adding storm surge that we're likely to get from a Category 1 hurricane, it starts to look kind of shocking. And then Category 2, and we're looking like 4 feet of sea level rise at that point, what it looked like when we just had the still ocean. So this is kind of a useful map to show you how vulnerable Miami Beach is. And there's actually some really useful information on here about how much population would be affected by these 2 sliders, broken down by ethnicity. So a Category 2 hurricane, even if we take it down to 0 feet sea level rise, is going to affect 91% of the population on Miami Beach. And it will affect $48.6 billion worth of property. This also tells you the kind of infrastructure that's going to be affected and the different land uses. So it's a very useful little tool to get an idea of how important sea level rise is to this community. Okay, so this, I promise you, this is near the end of all these acronyms. So Going back to the architecture side of this, particularly if you're building on Miami Beach, you need to know a few terms. One is the base flood elevation, BFE. And this is an elevation that is given out by FEMA, which is the Federal Emergency Management Agency, to get flood insurance, basically. So that's something you need to know. Your finished floor should be at least the base flood elevation. Miami Beach has something additional, which is called freeboard. And freeboard is an elevation above the base flood elevation, which kind of allows for errors in the flood. For instance, say if your house is near a canal, and during a flooding event, that canal gets full of debris, and then suddenly you have more water piling up behind that debris and cannot escape. The freeboard kind of gives that kind of safety net during these flood events. And then something else you'll need to know is something called hydrostatic pressure. So once a building gets flooded, there's a lot of pressure on the walls of that building, particularly the foundations. And so hydrostatic pressure builds up from the water and actually can cause structural damage. So in the Miami Beach Building Code, which we're going to go to now, and I'm going to give you this link, particularly on the floods. If we do a little search for freeboard, we can see that they give us a definition. So freeboard means the additional height, usually expressed as a factor of safety in feet, above a flood level for purposes of floodplain management. Freeboard tends to compensate for many unknown factors such as wave action, blockage of bridges or culvert openings, and hydrological effects of urbanization of the watershed. So this is kind of a safety factor. And in the building code for Miami Beach, they have a freeboard minimum of 1 foot, and they have a freeboard maximum of 5 feet. So when we scroll down here a little further to find the bit about new residential construction and new non-residential construction, we can see there's rules in here that all new construction has to be built to the lowest floor of an elevation of at least 1 foot above the highest adjacent grade. And then they show us further information that all new construction and substantial improvement of any residential building shall have the lowest finished floor, including electrical, heating, ventilation, plumbing, air conditioning, cable, etc., no lower, I've got to move this, no lower than the base flood elevation plus minimum freeboard. So the lower finished floor level has to be 1 foot, as we just saw, above the base flood elevation, to a maximum of 5 feet above the base flood elevation. So how do you find what the base flood elevation is? Because you need that number to work out where your freeboard is. Well, that can be found at FEMA's website from the National Flood Hazard Layer. So hopefully that's going to open. Yeah, there we go. So when you get to FEMA's website, you're going to go to FEMA's Map Service Center. And there you can put in an address. So let's just make one up. Let's try Alton Road in Miami Beach. And this is going to bring up the flood map. It takes a little time while it grabs the latest data. So hopefully this is going to display. Yep, there it goes. And so this is our address that I just put in, 1201 Alton Road. And then we have a bunch of other information that slowly loads in. So what we're seeing here, we've got this cyan overlay, which is telling us we're in a special flood hazard area. And if we look here, we can see we're in zone AE. And this is the base flood elevation, 8 feet. So if you were building anything in this area, your finished floor would have to be 9 feet. So it's the base flood elevation plus the minimum 1 foot freeboard that Miami Beach requires. You could also add 5 feet to that, which is the maximum, and that could be your finished floor level. Why is this important? Well, there are also building height restrictions in Miami Beach, and anything up to the freeboard, so your base flood elevation plus the freeboard, is 0. That's the 0 point for your building height. So that's where you would start the measurement for your building height. So it gives you quite a lot of leeway to go further up. I just have to, 1 second while I just let my dog out who's scratching at the door. So this is where you're going to get your base flood elevation from. And you can actually click this dynamic map and it will download what's called a FIRMET, a flood insurance rate map for you to use in your project. It does take a little while to generate that. So it could be a couple of minutes while it generates it, and you'll download it as a PDF like this. And then we can open that PDF and you get that whole map, so you can give evidence that this is the base flood elevation. Now, all of this really should be done by a specialist, and FEMA has map agents that you can help with this, but for this particular project, you can use these FIRMET maps. Okay, so now we're going to get to a much more interesting thing where I'm going to show you a demo of the Gizmo plugin inside Grasshopper. So this is going to help you get site context. So let's swap over to this. So I've used a little bit of an area in near Brickell, actually. And we're going to use this plugin to bring in the buildings around your site. And then this is a very basic parametric building that I put in this empty site. I'm going to bring up Google Earth so we can see where that is. So this is a site in downtown Miami, near Brickell Key. It's an empty parking lot at the moment. So we're going to use this as the reference for this example. So this is what we'll end up with. And then what we will do is take that and put that into Revit. We'll transfer this directly from Rhino into Revit with a new plugin that's called Rhino inside Revit, which will save you a tremendous amount of time. So let's go back to our Rhino file. Here we go. Let's just close this down. Okay, so a couple of things. I'm going to start a new document so that we can go through this from scratch. So what I'm using here is actually Rhino 7, and I recommend all of you.
Can I help you?
Say again? Is that a question? Nope. Okay, so what I'm using here is Rhino 7, which is the latest version released by McNeil. You will need this version to use the Rhino Inside plugin. So this is a blank Rhino document, and I'm going to open up Grasshopper. And I think, Thomas, you sent out a link to everyone with all the links to the software for everyone to install, correct?
Yes, and to all colleagues.
Okay, perfect.
Is it possible for you to go over how to like put them into the Grasshopper?
The instructions are really detailed on the Gizmo site at the link. Is that what you're talking about? How to install the plugin?
Well, I was talking about the other one.
Which one? Rhino Inside?
The E one. What is it called again? Starts with an E.
Oh, Elefront.
Yeah, that one.
Okay, yeah.
Yes.
Yeah. Basically, you just have to drag it onto the Grasshopper canvas.
Just one quick note for a lot of these plugins that you would be downloading, if they come as a package, you want to make sure that you right click on it and you unblock them. So depending on your computer's security setting, this might be an issue. So then when you install them, whether by dragging or by adding to your component special folders, they might not appear, right? So you just want to, as a technique, just always right click and make sure that there's no blocking issue.
Yeah, so what Bjorn is saying is anyone who's using Windows 10 and hasn't changed any of the security settings, if you download any of these plugins for Grasshopper and some of them for Rhino and Revit 2, you're going to download them, and I've already unblocked this one, but you're going to right click on it, you're going to press properties, and in this area just here where it says read only and hidden, there'll be another thing that says unblock. Before you unzip any of the plugins that you download, always right click, check the unblock, click OK, and then unzip it. Otherwise, it will be blocked from running on the operating system. Every single plugin, if you read the instructions on the install instructions, the first thing they'll say is right click and unblock. So
precisely. So always take a look at the TXT file either on the page or within the package, and because if you have issue that a million other people have as well, so just read the instructions, but the first default thing might be the unblocking issue and the security setting on your computer.
Yeah, because what happens if you don't unblock and you unzip? What's going to happen is you're going to have a ton of this is one I've already installed, but all the files will be blocked that you unzip. So you'll have to go through every single one and unblock them for it to work. So if you're having trouble installing them or they won't drag onto the Grasshopper canvas, it's probably because it's been blocked. That's the number one thing that stops one of these plugins working. So check that first. But if you do need any further instruction, like Thomas will give you my email, and you can always email me. Okay, so we're going to go back to Gizmo to get this site context in. There's a couple of plugins that do this. One is called Elk, which requires a little bit more understanding of Grasshopper. Gizmo is a little bit more user-friendly. So once you have it installed, you're going to drag this little penguin, the Gizmo penguin, onto your workspace, and you're going to use a panel just to check that it's working correctly. So you can create a panel by double-clicking on the canvas and doing 2 forward strokes, and you can connect this to the Gizmo plugin. If everything is successfully installed, because you have to install something called MapWinGIS also, you'll get this Gizmo penguin is peeping, I guess, and it will show you where your folders have been installed. So that will mean that this is functioning correctly. One of the first things we're going to do, though, is so this plugin is going to read data from OpenStreetMaps, OSM data, which is an open source repository for mapping. And this is great for just bringing in site context to be working with in projects like this. So the first thing we're going to do is go over to OpenStreetMap. And like magic, it goes to the place I want to go to. But what you would do is zoom into where your site is. And what we're going to do from this is actually get the coordinates of the site. So this is the site in Brickell that I'm going to use in this example. I'm going to right click on it. I'm going to do show address. And then what's going to come up here is the coordinates, the longitude and latitude for this, this property. So I'm going to copy those, and then I'm going to back over to Grasshopper. And I'm going to, the first thing we're going to do is create the location. So that point is going to be the center of my site. So we're going to do the Gizmo create location plugin. Okay, so this is asking for 3 things. It has the location name that it wants, a latitude and a longitude. So we have that information. I just pulled it off. So I'm going to create 2 panels with that information in. So my first one, I'm just going to edit it and just take out that second number. And I'm going to create another panel with the other number in. So this number is, this is our latitude, this is our longitude. And a good thing to keep these organized is to right click, and let's just rename these so that we remember which is which. Oops, right click. And I'm going to plug these in to the appropriate inputs on this component. And I'm going to create another panel, 2 forward strokes, and I'm going to call this Miami, Florida. So this is information going into this location. And this is going to pull data from this point from the OSM map. If we hover over here, we can see that it is pulling the latitude and the longitude from OpenStreetMaps. Now this works a little bit different from ELK. If you ever use the ELK plugin, which you require to create like a square, a polygon of what you want to use. This is going to create, this is our center point, and we're going to go out from that point. So we're going to do a radius. So let's create another panel, and let's say our radius is going to be 300. I'm going to rename this radius. Okay, so this is in whatever units your document is in. And if we look down at the bottom here of Rhino, you see I have feet down here. So this is going to be 300 feet. Okay, so the first thing we want to do is grab some of that building data that we have in OpenStreetMaps. So if we look at OpenStreetMaps, you could query any of these buildings, and it gives you information on this side, the yacht club, and it gives you height information. So we want to pull all this in and have Gizmo create these geometries for us in Rhino. So to do this, we are going to pull another component, which is the Gizmo OSM shapes. And we're going to add this to our canvas. And we're going to, you can see from this, so that this requires a location. And any input on a component that has this little underscore at the beginning means that that's a required input. So I'm going to take the location and plug that into there. And then, as I mentioned before, this is the starting point for the data that it's going to pull in, and then it's going to go out from a radius from there. So I'm going to plug that radius in here. And then this has a few other inputs. So it has a shape type. If we hover over any of these inputs, it tells us a little bit more. So we have 3 shape types. We have polygons, polylines, and points. And these will represent different types of data from OpenStreetMaps. So we've got to remember this. So let's make a number slider here that can go from 0 to 2. And we're going to start it at 0. And a quick way to do this is double click the canvas, put your starting number, 0, 2 dots. I want it to first start on 0, 2 more dots, and we want to go up to 2. And that instantly gives us a number slider. The middle number represents where it's going to be positioned when it's created, and then it goes from 0 to 2. As we're going to be looking at building footprints, those are polygons, so we need to keep it at 0. Okay, so the next thing is required keys. Now this is something that OpenStreetMap uses. It classifies its objects like buildings, parks, trees. So we actually have a Gizmo component called Gizmo OSM objects. So we're going to put that on the canvas, and this gives us the list of all the keys that are in OpenStreetMaps. And then we're going to Gizmo OSM keys. We're going to add one of those to the canvas, so we can plug in Gizmo OSM objects to the input here, which is required. And the required keys we can send out here into our OSM shapes component. Okay, so we don't see anything yet on our canvas. So what's going on? This is a plugin that requires a toggle to run it. And this is, again, is a required input to this module. So we're going to get a Boolean toggle. So I'm going to double click, start typing Boolean, grab this toggle, and plug it into the run it. So this toggle is just going to go false or true. When I double click the false, it's going to change from false to true. And if I double click it again, it will change back to false. So to run this plugin, it has to have a true Boolean sent to it, which is a 1. So if I double click, there we go. Okay, so we've got buildings, and let's look on our map, and there we go. So we instantly have the building footprints, which looks very much like Google Earth, I think. Yeah. Okay, so this is useful, but we kind of want to have a 3D geometry to work with. So what I'm going to do is there's another component called Gizmo OSM 3D. So we're going to add that to the canvas. And we're going to connect the shapes to the shapes, the keys to the keys, and the values to the values. And again, nothing's happened. This plugin, again, requires a little toggle. So I'm going to copy this toggle by starting to drag it and then tapping the Alt key, gives me a copy. And I'm going to plug this into run it. As it was already set at true, it's going to run the component, and there we get the 3D buildings. Okay, what I like to do is actually grab a geometry component, and these are the 3D shapes that are coming out of here. And then I like to just, let's disable the preview on those so we keep this nice and clean. And for those that don't know, you can add something called a custom preview. So we can go custom preview. And we can add a swatch, a color swatch. There we go. We can change this color by dragging on this little box. And we can add that in, and then we get a custom preview of any color we want to of our buildings. Okay, so we got our 3D buildings in. OSM has a ton of data. You can scroll through this list to see the types of stuff that they have. But let's see if they've got any tree data. So this is polygon data. Let's look for point data now, which would be something like a tree. So what I'm going to do is, first of all, I'm going to do a little housekeeping. So I'm going to move this over. I'm going to group these, which can be done by pressing Control G, or if you have a mouse with a scroll button, you can click down on that mouse and group them. So we've got all of this grouped. And there's a cool feature that if you double click and start typing scribble, it's a little text item. So let's remember that this is creating 3D buildings. Drag this up here. I'm going to click on the group and add this to the group. So now all of this moves around together. So now I want to look at some point data, which are trees. So I'm actually going to grab this group, and I'm going to do the same thing I did to get a whole new group down here. And I'm going to change this to create 3D trees. Okay, so for this one, we have this already operating. So I suggest you turn these to false while we start adjusting data. And I'm going to do the same thing. I'm just going to group these. Okay, so this time we want to look for trees. And we know that trees are point data. They're not going to be polygons. So we need to change this to 2. Okay. Now in this panel, so let's run this and see what we get. Nothing yet. So let's see if we can make the 3D trees out of this. So on this panel, we have a couple of things. We have that we need to look at when we're making trees. We got a tree type, and we got the random height range. So these trees are just point data. So what we can do is give these trees some height. So I'm just going to move this over a little bit. And to do height, it actually, if you look at this, it needs a domain. And a domain is basically just a range of numbers. So like 10 to 15 or 10 to 20. And these numbers are going to be in the units of your document. So we're going to do something called construct domain. If I can spell it right, here we go. So a construct domain is going to ask for a start number and an end number. So let's think of like an average tree. Let's say it's like 12 feet to 25 feet. So I'm going to create 2 numbers, 12 and 25. I'm going to plug those in. So this is going to give me a domain from 12 feet to 25 feet. I'm going to plug that into my random height. Okay, let's run this and see whether we get anything. And there we go. So now we have our trees. So this is point data using the tree key. We can just use this to change the colors to something more tree-like. Okay, so that's got some trees. So this looks like it's Brickell Avenue, and there's some tree data there. With OSM being an open source mapping software, it doesn't necessarily have every single piece of data in there. This is obviously a prominent boulevard, and someone has taken the time to put that tree data in. Okay, next thing. So let's get some roads in there. Okay, so I'm going to do the same thing. Select this group, start to drag, press Alt. And I'm going to change this to create roads. Group those. And again, before starting, let's turn these to false so that we don't overwhelm Grasshopper. Now the roads require a little extra step. So these are kind of built into these components. Roads, what we need to do now as we start filtering down the types of OSM data, we need to do a tag search just for roads. So there's 2 components to help us with this. There's Gizmo OSM tag. I'm going to put here. I'm going to move these over a little bit. Add that to the group. And Gizmo search. Okay, so what this is acting as is like a filter. So if we want to look for roads, let's choose our roads. What's going to happen is, and we got to think that roads are not polygons or point data. They're actually polylines. So we need to change this shape type to 1. And if we run this, we don't really get anything, right? We're not showing anything on here. Reason being, the preview on this particular component is turned off. So if we look at this, this doesn't really look like, I mean, it looks like there are some roads in there, but it also looks like there's some other data in here, some coastlines and some other kind of the parking lot and things. So this is actually giving us pretty much all of the polylines. And the way Gizmo works is it can parse out building and tree data with these plugins. But for any other thing, we have to search for that particular tag and then filter that out. And it's quite easy to do this. We're going to take the road object, plug it into here. Then we're going to plug this into here.
To end your call,
Is that a question? And then what we're going to do is use this to filter out the roads. So I'm going to connect those into there. And then if we turn the preview off on here, again, make sure you note that run it is a required input. So we're going to bring a Boolean toggle over and run. And now you can see we're just getting the roads out of there. So this is great with any other. So if I want to change this to, where's coastline? Coastline. I'm just going to get the coastline category out of there. So let's change that back to roads because I want to show you how you can create surfaces from those roads. Okay. So for the roads, there is also a particular plugin, which is the 3D road. So what you're going to do is plug the found shapes into here. And then this gives us a couple of options. We can do a road width and a road thickness. And as you can see, if you leave it at the default, this is going to be approximately 10 feet. And this is going to be approximately 0.8 feet. So if you wanted roads that were 20 feet across, we'd create a little panel with 20 in there, click it into the road width. Nothing has happened, right? Again, it's one of these plugins where the required input is a toggle. So let's click on Alt, bring this over, and add that into there. And let's see, give it a moment, because the roads plugin is one of the few components that takes a little while to work, so 9.7 seconds. But you can see what we're getting now is some road surfaces, which is very useful. I just want to note, let's get rid of these. If you're using 7, I've just been in contact with the developer. This particular component has a little bit of an error with version 7. And it's just one line of code, and I worked with him to sort that line of code out. But basically, if you do get an error, you're going to double click on this component, and you're going to get this Python window come up, and you're going to go to line 610, I believe it is. Yeah, 610. So if you're getting a little error on this, go to line 610, and all you're going to see is like 2 equal signs and 6. You've got to change this to a greater than equal signs and 6. This is just telling it that if you are using Rhino version 6 and greater, then to use a different instruction in Python. So if you have an error, he hasn't been able to fix it yet before this tutorial. So just change the Python code in there, click OK in the top corner, and that error should disappear. So now we've got our buildings and our roads. Let's look about getting some terrain in here. So Gizmo does have a terrain generator. And the great thing about this terrain generator is it uses a couple of sources. And one is the SRTM, which is the Shuttle Radar Topography mission that was conducted in February 2000 by one of the space shuttles. And this did a radar scan of the Earth and created a topographical map of the landscape. So this can automatically bring this information in. You can actually go to I think it's the USGS or the NASA website and download this, and you have to search for it and look on these maps for your particular region. This is actually going to go and grab that for you. Of the 3 sources that are on here, the SRTM is actually the highest resolution. particularly for North America. It's 1 arcsecond, which equates in our part of the Earth to about 30 meters. So it's a 30 meter by 30 meter resolution.
Sorry, Darren, to interrupt you. I just pasted the JPL's website. It will take you to the SRTM too. And for those of you that took computer practices, this is the same resource that we use for the ELK SRTM. So in this component, this is kind of embedded as one of 3 options. But that's where
and SRTM is good to use. The only thing with SRTM is in some areas of the globe, where it doesn't cover some areas of the globe, but in other areas of the globe, there are voids in the data, and there also is some interpolation of data to create a smoother surface. So there's actually a much higher resolution now, and of other data, particularly LiDAR data, is a much higher resolution. But for purposes,
really annoying.
Someone mute there.
Probably like one of the worst Nintendo characters. The worst Nintendo character.
Yeah, thanks, Thomas.
I'm always muting. I have a panel, to mute people.
Yeah, thank you. LiDAR data is much richer data. And what we'll see from this data, if I go over to Google Earth, which kind of uses some of this data, if we're in Google Earth, we can actually get an elevation profile of the area by going up to the ruler tool up here. And it goes straight to line, and you can do a line like this, save it, elevation profile. And then you can click on your saved line and do this show elevation profile. So what you get is, this is kind of taking some of that data, and you get, plus they're using some of the more advanced LiDAR data, and you can get an elevation profile of the line. And what's great is you can see where you are along that line as you move along. Now, the only problem with this, and it's also a problem with the SRTM data, is buildings. Buildings actually kind of interrupt that data in some ways. So if we actually go along here, look, you see this hump here up to 30 feet, that's actually I-95 causing an interruption with that data. And you'll see some of these buildings might actually create some interruption with that data. But you can generally see that we're kind of 3, 4, 5 feet, really. And then we see the little limestone cliff probably. So this is a good little thing if you want to get a nice section profile of your site. So what I'm going to do is show you the SRTM data and show you that there may be inaccuracies in it. So let's bring that data in. So first of all, it needs the location. So we are going to bring the location that we've already got down here. And we're going to bring our radius. And I'm going to show you a little problem with our radius in a minute. The source it defaults to 0, which is the SRTM data. And the type, what I want to do is create a type 2, which is a terrain with a surface with the rectangular edges. You could use number 3 as well, which will give you a circular, which will actually give you the 300 circular, but I want to use type 2 because this plugin also allows you to adjust the building bases to the terrain. So I'm going to use type 2 here. And again, this is one of those plugins that has a required input to run it. So I'm going to drag and click Alt to copy this and plug that in. Let's let that run a few minutes. So it's pulling this data in. So in the background, it's downloading this to the Gizmo folder, and here we go. So we've got the terrain data in. So one of the first problems I see is it's not covering my entire area, and that's because any portion of the building that's in the 300 foot radius it's going to pull the whole thing off in, and because we're just looking at a square, The best way to fix this is to use the addition and give an extra kind of buffer to this. So let's add a 200. Let's add a 200-foot buffer. So what we're going to do is bring in our radius into here, add the buffer onto it, and send the result out here. Again, it's going to have to now go to the website and pull that terrain data in, which give it a few minutes, and there we go. So this covers pretty much the area we're looking at. But here is how I want to show you that there's some inaccuracies in this data. For instance, let's look here. So we know there's not hills here. So when they did and this is from 2000, remember? So there were probably some buildings here that are messing up the radar, because certainly when we look at this in Google Maps, we don't have any hills going through these buildings. So for this particular case, where we are using an area of land, a site that's particularly flat. We know Miami is particularly flat. I think the best way to do this, to give us a rough site context, is to look at it in Google Maps. I can see this site is pretty flat. You know, it's all been leveled off for the building. And I can tell from my profile here that, you know, this is around 3 to 4 feet. So the best way that I think we can solve this issue, maybe Biana has other suggestions. One, you could go in and you could bake this and you could start adjusting some of this, but that just seems like too much of a pain when you have an area that's particularly flat. So I'm just gonna go over in here and I'm gonna produce this rectangle by 3 points. I'm just gonna map this out roughly to here. Okay, I'm gonna go into here and I'm gonna create a new layer, terrain. I'm gonna select this, change my object layer, and I'm going to just estimate this to be from the profile 4 feet. So I'm gonna raise it 4 feet. And then what I'm going to do, as you saw earlier in my grasshopper, I was able to find a coastline. So let's just change this to the coastline. And I'm actually extruding it with this. So I'm going to turn this off. Okay, so you see I have a coastline there. So I'm going to bake that coastline. I'm just going to put it on a default layer for now. So now I have that as a real thing. I'm going to go to my top view. Let me set these back to my defaults. I'm going to go to my top view. I'm just going to turn off this preview so we don't see the thing that's there already. So I'm going to use this to trim this surface. Okay, so I'm going to select the line I want to use to trim. And if you use top plan, it projects down. So I'm going to use trim, and I'm going to select the surface there, and then I get a nice base surface to work from in my perspective. Okay, I'm going to turn my preview back on in here, and we can see that I think that represents it a little bit better than the SRTM data. I'm going to turn this preview off at the moment because there's a great thing that we can do, and that is we can move all of the buildings and trees and even the roads up to this terrain. So we're going to reference it. So I'm going to bring in this surface by using the surface reference component, and I'm going to right click on it and do set one surface and click on this. And then what I can do is actually use this surface and plug it into the ground terrain here. And you saw my buildings went up a little bit. It's just 4 feet, but now we know that they are touching the very bottom of this surface. And I can do the same for the trees and the roads, etc. So you're just plugging it into the GSM, the Gizmo OSM 3D ground terrain, and that is going to bring all of that up. So I think that, and Thomas, do you agree that this is probably with a relatively flat site, with all those discrepancies in the SRTM data, it's probably better to do something like this and at least just get your base elevation.
We will match with that at least the beginning of the AIA and NAP and NCARB criteria, but we still have to do the section.
Right, exactly.
So maybe one option, one option would be, I have a tutorial here, and this was, this is there's a longer way of doing this, which is just finding center of each building, projecting, moving them up, but so that's also possible. So I just pasted a tutorial here, which is using OpenStreetMap data, and it's doing the same thing. So it's possible. I mean, again, it's not going to be 100% accurate, but I think it's important to then think about even how do you kind of create a common datum for all buildings to be considered as let's say, because we know that, let's say, the site is never flat. In this case, the logic that I'm using, you take the centroid, you project, you move, and there's always going to be, let's say, inaccuracies, right? So that might be one way to address this, but I think it's more of we find the closest, relevant.
Yeah, so that is actually built in. So I don't have to use this reference surface, right? I can use the SRTM data. So if we turn this preview back on, and I just take the preview off here, and you can do that exact same thing in here. You can, between the shapes out and the shapes in here, you can put an algorithm that would take the centroid of this shape and move it up to wherever point is on this this topography. So we can do that same thing without having to create that by taking the terrain from here and plugging it into the building here. And that's going to move them all up based on the centroid and the terrain that it's pulling in from SRTM. That may be fine, but we still have the issue of this terrain going through this building like this, which when we look at Google Earth, we know just doesn't do that. So I don't know, at this point, I feel like when you have, I mean, yeah, that's a way to do it. So if people want to do that, you can bake this terrain into your model. Let's do it here. Let's turn off this preview, and we can hide this terrain here, and then we can bake our buildings in as well. So we can do that and put those in. Actually, let's just create to keep this nicely organized. We should create a new layer for each of these. And we can bake our buildings onto that layer. So that's giving us pretty much that same thing where it's, and this goes a little one step further and actually trims the buildings off to the terrain, which may be a good thing, may not be, but this actually is completely matching the terrain. But this is really not I mean, this is about, if each one of these is a foot, this is like, I don't feel this represents what that coastline looks like. So I think a workaround is to create that surface and look at the elevation profile.
So one way might be that we could either look at the other two sources that Gizmo can provide. The other thing could be look at the, let's say, SRTM, the other two resolutions, because there's 3 resolution. Obviously, it's less, but just because basically this comes from the fact that the satellite image, the remote sensing, wasn't processed properly, and there was a dark, there was a bright spot that then was understood as elevation. So these things are quite common, and as let's say the algorithms get better for classifying rooftops versus, let's say, streets, surfaces, hopefully these would be troubleshoot. But I think these are interesting way of also thinking about even how these machines are, or how these algorithms understand, let's say, certain information from top, certain information based on what's already in the GIS. And we will look more into that on Thursday, further into OpenStreetMap and other workflows as well.
So thank you.
Yes.
Darren, can we go then to the Revit workflow? Rhino and Revit?
Yeah, so once you have all this in, you know, the SRTM is a lower resolution output than some of the more modern ones. These plugins don't use that. I don't think Elk even does anything. Oh, I think they use GeoTIFF as well. I think you can use GeoTIFF in Elk. Yeah, so for those that are not completely happy with, you know, understanding how to do Grasshopper, I think this is a nice plugin to get you context very, very quickly. So what we're going to do is make sure when you bake all of this stuff into Rhino that you know, put them all on separate layers, that it's all classified correctly, your roads, your terrain, etc. So what we're going to do now is go into Revit. And I'm going to open a new document in here. Let's just close this one down, actually. Okay, so if you have, just hide this panel, hide video panel, hide floating meeting controls, there we go. So if you have Rhino Inside installed properly, it will show up in your add-ins. So you are going to click on Rhino 7. Make sure you have the latest version, which I think is 7.2 at the moment. And what this is going to do is actually open an instance of Rhino and Grasshopper. Well, it's actually going to open an instance of Rhino inside Revit. And then what you'll be able to do is open an instance of Grasshopper inside Rhino inside Revit. So we're going to open Rhino, and it will show up just like your standard Rhino. This is a completely different instance of Rhino. So all the settings when you first open it up will not match the settings that you have set in your standalone version of it. So you may have to do a few bits of adjustment in here. So I'm going to open Grasshopper, and I'm going to open this this Grasshopper script, and I'm going to give this to Thomas to send out to you. But I want to talk you through it. So first of all, I'm going to open my file that I just created. Okay, so you can see this is the site here that we just pulled in. This is using the 4-foot site. I've added some water, and I've just put in a you know, your reference conceptual mass. People had terrible trouble getting geometry out of Rhino into Revit, and it was just a real nightmare to do. This new plugin from McNeil has really made everything so much easier, and I'm going to talk you through the various things. So I want you to note that I have this all nicely organized into different layers, and we're going to use the Elefront plugin, which allows us to select geometry on specific layers and filter that geometry out. So this is a way of just grabbing all the geometry on a particular layer and then sending it over to Revit. So I'm going to talk you through. Is it large enough? Everyone can see this pretty clearly?
Yes.
Okay.
Yes.
So the way this plugin works, we have in the parameters, you'll see a new little section in the toolbar called Revit primitives. And this is really for grabbing reference material out of Revit and bringing it into Rhino. But we're going to look at this new toolbar called Revit, and this is going to be the basic way of getting geometry out of Rhino into Revit for conceptual analysis and for getting drawings in Revit very quickly. So we're going to use something called direct shape. And this is, we're going to use the add geometry direct shape to get geometry from Rhino into Revit. So the way this is going to work is, I'm going to use this Elefront plugin called component called reference by layer. I'm going to create a panel and tell it which layer I want to bring in. So I want to, if I select objects on this layer, it's going to bring in all my context buildings, right? And I want that on a separate layer. And I'm going to filter this layer with the Elefront component called filter by type. So it's going to bring this layer in, and then I'm going to filter it by BREPs. BREPs are basically these representations of the geometry that Rhino is creating. So these are closed, what are called closed BREPs. These are solids. And then I'm going to send this over to this add geometry direct shape that I have here on the canvas. So I'm going to take the geometry from there and send it over to this direct shape. Now, for those of you that are familiar with Revit, it's items in Revit are categorized. So you've got walls, you've got doors, you've got windows, roofs, ceilings, floors. These are all top level categories in Revit. And we have a models category picker, which is also in the Revit toolbar. By the way, once you get these Grasshopper scripts from me, if you ever want to find out where one of these components lies, press your Control and Alt key. You'll get this little eye come up, and then click on it, and it's going to show you that it's in the Revit, and then it opens up all the menus and circles them. So you can find out where that comes from. So you see that's the model category picker. So this has all of those high-level categories in Revit, and this is how we want them to show up in Revit. So for these context buildings, I'm just going to bring them in as generic models. We can also add materials as we bring them into Revit. So I'm going to choose the query materials component from the Revit tab, which is found there. And I'm going to use a values picker, which is a standard component from Grasshopper. And that can be found in the parameters with the checkbox. So if I connect this materials query, it's going to query all the materials that are in this particular project. So if you want to add additional materials in, you can, and they will show up in this filter mask. And then you can scroll down through all of these materials that are available. So these are conceptual mass context buildings. So let's just use concrete lightweight. So as you can see, this is my Rhino model. This is my Revit model. Let's put this in a 3D view. You can see how it's all going on. And then when I enable this plugin, this component, you'll see it working in the background. Oh, and one thing, once you enable this, you need to click update here because this has already processed this data. So what we're seeing here is it creating a bunch of masses in the background and sending them over to Revit. So you have all of these selectable real objects now in Revit. And you can make changes. So just to show you how interactive this is, let me just move this building over here. Okay, so that's that one. I'm going to click update here. I'm going to go through the process again and move that building. So all of this now, if I click on one of these, it's going to come up as generic model here in Revit. And all of this can be processed using all the Revit features. So let's bring in this terrain. So I'm going to do the same thing. I'm going to choose my layer terrain in Rhino, send it through Elefront. I can choose a material. So let's choose I don't know, earth would be good. And then I'm going to enable this and make sure that I do update here. So there is my Earth that's come in. So we're seeing everything in red at the moment. That's because when we go to our Rhinoceros tab, we have a preview already on here. So we can turn that off, and then that gives us a better representation of our model. We can turn this to fine, and we can do shaded and see our model in there. One thing I want you to know is these have all come in as individual elements in Revit. That's because I am grafting the items that it's finding in that layer in the geometry, and that's just by right-clicking and choosing graft. If I turn this off, it's going to go through the whole process again, but now when I click on it, it's coming in as just one object. So this is thinking that these buildings are all one object. So I think actually it's better to have graphed on and have them as individually selected objects. And of course, now you can, turn on your shadows and your sun. And let's put the sun to still and do winter solstice. Now you may think, oh, that's a little bit weird. Yeah, we need to set our location. So if we go to analysis and we go to location, we are going to go back to OpenStreetMap, and we're going to grab that location that we had originally in OpenStreetMap. And we're going to put that in here, do a search. Yep, that's exactly what we want. So I'm going to click OK. And we'll see that our shadows have now changed because we're referencing Miami, that particular address in Miami. It's very important that you set this location at the very start of your project, because all of these analysis tools will be set to Boston otherwise, which is the default setting for Revit. So I'm going to give you this particular script. What you've got to bear in mind is you may have to change some of these panels to match the name that's in your layer. So the best way to do that, is actually to double-click, copy, and paste over here so that you make sure that you get the exact spelling of your layer name. This script also has, we can bring in, I created a seawall, but we can bring in the trees, same thing, enable this, click update. Give it a little time to process. And now we have all our trees in Revit. Same thing with this conceptual mass that I created here. It's a little bit more than a conceptual mass, but it's got some floors and a roof and everything. Same thing. I can choose my walls layer. I can set the category to walls so that Revit knows that these are walls. I can choose a material. Again, I can enable this, click update on Elefront, and we start getting our model in here. So this is the walls part of this model. Here we can add the roof. I've selected one thing, I'm choosing roof. I'm gonna enable this, update, there is my roof. Same with the railings on this, enable this. When you get this script, these will all be turned off. So you've got to remember to enable them. That's adding the railings, adding the floors. And another great thing about this is you can do things like add levels. So I want to show you that very quickly. So I'm going to look at an elevation. So you can see that there are 2 levels in here already. I'm going to get rid of those levels because I want to create my own. And we've got a little script here, which is doing a little series. So you remember I set my base level to 4 feet for my terrain. I know that my floor heights are 13 and I've got 45 floors. So I'm creating a little series that starts at 4. We'll step up 13 feet each time and count 45. And then I'm going to use another series here, which starts at 1, because I want this to label each of the levels. So it starts at 1, counts up to 45. And then I have a fragment of some text here, level with a space after it. I'm going to concatenate these. So I've got level 1 to 45. And then I'm using this component, which can be found here in the models, to add levels directly into. So I click on that and instantly we have these levels added into the model. So once you've got that in there, you can use these, if you want to create a section, for instance. So this marker here in blue is the exact coordinates of our site that we entered in location. So if we want to create a section through this building, we can just draw one. Let's pull this field of vision out further. Double click on this, we'll bring up our section. And then you can just use something like visibility graphics to start showing all of these areas. So because we've categorized these shapes. So if I want to look at the walls, I know that the walls have come in with the correct category. So I can go to visibility settings. Where the walls are cut, we can change this to a solid color, and we're going to choose black. And these actually don't have much thickness on them, so it's not going to show up, but let's look at floors. Again, we're going to use the cut override. We're going to choose a solid and a black and apply that. And there we go. So we're getting we're going to see those cut marks in this. One thing Thomas did want me to show you is, Thomas, you like a lot of your stuff to be transparent, right? Your massing.
Yeah, I would like to see conceptual massing as an X-ray translucent, so we can orbit and dive in, dive out, and discuss during the design process.
Okay,
as we no longer can read very well 2D. We are really working in ND workflows. Thank you.
Okay, so there's 2 ways you can do that, and I'll show you in Rhino and Revit. So in Rhino, one way you can do it is I can select all the elements of my building, and we have this in Rhino 7. You have this little viewer color picker here. You could choose a color and then bring the opacity down here, and that makes it semi-transparent. You may have to adjust it down even more. That gives you like a transparent building. Let's just pull that back up. The other way is to select all the objects on those layers. So I'm going to click this and do select objects, and then you can use the command called set object display mode. Click enter, click on the mode, and you can use the ghosted mode, and that will give you some kind of translucency. It's not as much as the transparency, but you can see there is like some kind of, I can see through this roof to the lower level. So depending on how much you want to use, you can either do it here or set the view, set the display view to the object. In Revit, it's annoying that they both begin with R because you forget which one you're using in there. You can do a similar thing by clicking off an object and using visibility graphics. And you can set a transparency for those particular objects if you want to. So you can go into, let's do floors first. Actually, let's do the roof first because that's the top thing. So you can go into here and you can select on the transparency, click override and add some transparency to that and click apply. And that's probably way too much. It's quite sensitive, Revit, to transparency. You probably need only 10%. Yeah, and that gives you some transparency, and you can do the same with each of the other types. So your floors and your railings, your balconies, your walls, etc. That gives you transparency in Revit.
Darren, if I may add to this, why this is so important in sustainable practice, because this might be the first time for many students that they are not designing anymore as a sculptor, just doing free forms and nice forms, and not really paying attention to the interior, because here in sustainable practice, we're doing quantifications of how many people are in the building, what are the user loads for heating, cooling, what are the schedules for the space tax in terms of types from hospital to kindergarten, etc. Where is the circulation, where are the shafts, what is the MEP, what is the structure, and all these things, they actually create the form of those buildings. And at a stage after midterm, we will then use generative design workflows to massage and use topological optimizations by adding environmental parameters like sun, heat, wind, fuse, etc., etc. And that will be then the envelope. At this stage, we don't care about the envelope. It's all about quantification and structural systems, etc., circulation, egress, and all these building codes. The form for the envelope is a result of that. That happens after midterm, and we will have from Fusion 360 to Galapagos and whatever Caramba 3D. We're doing this generative design workflows then. So please keep this readable and understandable so we can assist you during the consultation. Thank you, Darren. Amazing presentation.
Oh, you're very welcome. I just want to make sure that, you know, the workaround that I'm using, obviously, if you were on a, because you're doing scenarios for 100 years, right, Thomas, in this
Yes.
project, like that workaround is really just to get, you know, a working site context for you guys. You know, if this was a professional project, you would have a surveyor, the ground would be surveyed, you'd have all those heights, someone would probably put it in civil 3D, and you'd be able to bring that into Revit and really work with accurate site data. This is just a workaround for those anomalies that we're seeing in the terrain data it's pulling in from the shuttle mission. So I just want to be clear that, like, this is a workaround, and you would have to have very accurate site data if you were doing this as a professional project.
So thank you very much, Darren, for this marathon through these new workflows that are very, very exciting. And I would like to announce that this Thursday, Biana and Albert will continue. Biana, you want to say something just quickly?
Sure. It was really I really appreciate your workshop. It covered a vast ground. So we're gonna try to build on what you've already done. And we're gonna start with a general introduction to GIS very briefly, but just talk about data types a little bit, and then talk about also looking at the data inside Grasshopper as well as inside Revit, which Darren started to do, and start to think about how this information can later on be extracted. With the Rhino to Revit workflows, a lot of people are really questioning how Dynamo is going to be rethought. So we're hoping that we're gonna begin to instigate some of these conversations, and then at the same time try to cover a little bit more, because this is a very interesting but fastly growing territory. Thanks.
Yeah, and next week I will then continue within Revit and show a couple of plugins and cover GPS Insight, and of course the Cove tool, and for the SketchUp users, Cyfira, and what else is on the market and works fine. And then I guess that's a lot of information. I would like to end this and say thank you to all the participants, and of course the presenter, Darren. Thank you for this, that you did this. And
very welcome.
I also want to thank to Crunch, because Crunch made this possible. It's funded by Crunch. And I would like to tell my students and Theodora's students that I'm going to close this, and you have to then use the other Zoom ID, because I need right now my Alienware to process this 2-3 gigabyte movie, I guess. And I cannot open up on the same machine again. If I use Zoom, it will collapse. So I have to go to another computer. So give me 10 minutes, okay? Michael, give me 10 minutes, and then we can have the private consultations. Thank you.
There's just a couple of questions. Sorry, I wasn't really looking at the chat. There's a couple of questions in the chat that I just want to address. Derek asked, will this consume a lot of memory when running Revit and Rhino at the same time? Yes, it will. And you kind of need to have a good graphics card as well. So if you have very little memory in your computer, it might be worth upgrading the memory. That will always make any of the architectural programs run faster. If you transfer a wall from Rhino, can you edit its face in Revit? This is from Derek. Also, yes. What you will notice when it comes in is that it's pinned. So to make any adjustments to the geometry that's brought from Rhino into Revit, you will first need to unpin it so that you can make changes, and then you can do whatever you would normally be able to do in Revit with that geometry, particularly if you have classified it correctly. Now, I just want to also clarify, this is the most basic way of pulling objects in from Rhino to Revit. You can actually pull them in as particular families and all of that stuff, which is a lot more complex than what we covered. And maybe later on in the semester, if that's something people want to learn about, maybe we can do another workshop on that. So this is the basic way of getting geometry over. You can take that geometry from Revit and pull it back into Rhino and work on it, all kinds of stuff. It's super complex and flexible, and can do everything and anything you can imagine between those two pieces of software. I think that's the only questions. Yep, so what I'll do is I'll send you these Grasshopper scripts this evening, Thomas, so you can send them out to everyone in D9 and Biana as well, if it's helpful to your group. Please just use them and experiment with them. And remember the Control, Alt, and click to find out where those components are placed in the Grasshopper toolbars. And thank you for listening. I didn't expect it to go on this long, so I appreciate you all sticking there. Still got 93 people. That's great.
Thank you, Darren.
Thank you so much, Darren.
Thank you, Darren.
No problem.
Great presentation.
Take care.
Okay.
Bye-bye.
I'm turning off now. Thank you, everyone. Bye-bye.
Thank you, Darren. Bye.